All right, so when you download the file, you will find this cluster. And this cluster is just the simplified version with the inputs and the outputs and a few things that you can use to change where it's located. So you can set a specific point and go, let's say set this point. We'll go here to set one point and change the location of that. Or you can also set a surface. So if I go here to plane, set one surface, I can use that as the input. So that is how you can use it to get started. But let's say you do have an input. The cool thing that we can change here is the rotation. So depending on which way you want it to rotate, right now it doesn't really matter. But let's say you have more divisions this way. Let's say if we have 5 divisions this way, change it to 6. It's an even amount. Well, now if we change it, it does matter. And sometimes if we change the multiplier to be 1, it'll actually make it slope like this. We can change the height, and all of the things that you'll see and you saw in the tutorial are contained here, as well as being able to maybe make it a little bit less wavy or more symmetrically down from the middle. The number of divisions and all of those things here. Loft option, now we have it as normal. You can also make it loose. So a lot of options you'll see within this cluster, and you can also edit it or look at how it's put together inside of here. As you can see, once you double click inside of the cluster, you can see exactly how it was made. You have the inputs, which are here, and then you have the outputs here. But you'll also have not just this, but the other script of the tutorial, you'll also have that available. But there's one last thing I want to show you, so give me 1 second, I'll set it up and I'll share it with you. This is the design I created using that same cluster here. So I used that surface as a reference. I projected a rectangle here and then created this structure, which is a set of I-beams and an outside structure. All right, the first thing we'll do is bring in a point. So I'll go here to construct point. This will allow me to bring in a parametric point, and I can change the XYZ coordinates for that point. Or if I bring in this point, then that will allow me to set any point in Rhino and change the location. Then I'll take this and move relative to the X direction. So here we'll go to X vector, or there's also another component called the vector XYZ, and we can plug in 2. So here we'll go to, let's say, 250 in the X, 250 in the Y. What that'll do is move it in both of those vectors at once. This way we can change the X and the Y extent. Now notice that once we do this in the positive direction, so positive 250 and positive 250, we can also do that in the negative direction. So I'll go here to negative and copy over the move component. So I'll slide it down, tap Alt, and I can plug in the negative instead, so it'll override it. And now we have 2 points. Here's the thing, since it's 250 here and 250 here, and 250 here, 250 here, we're actually doing 500 overall. So we need to take this vector and divide it by 2, so we can have the true size of the slider be the size of the surface we're going to be creating. I'm just kind of keeping this organized like this. And now we're going to bring in a rectangle 2-point, which is a way that you can create a rectangle starting with this point on point A. And this point is going to be point B. Now this is asking for a plane input. For now, we're just going to be using this point as, actually, let's go here to X, Y plane, and we'll use this as the input. Now, what I'll do is I'll take this and explode it into its 4 different line segments. So, explode curve. Now we're going to just pick the opposite items, and the way to do that is right now when you explode it, they're all within this component. So now let's bring in a list item. And we can now pick one of those. Or if we go down here and we add more than one, we'll go to the next one and then the next one and even the last one. And we can now take those two. So I'll extract both this one and the next one is going to be this one. Here's the catch. This and this line segment need to be, since the way that the rectangle is created is clockwise or counterclockwise, one of them is going to be oriented the wrong direction. So if I bring in a vector display, I think if we plug in this vector, it shows you this one is going in this direction. So this vector force component can show you that this one is then going in the opposite direction. So now we need to make sure that they're on the same direction. So what we'll do is now flip curve for one of these, and you'll see that now they're organized. So now that I'll disable the preview on this, we can change which one of these two by changing the index. So if we go 1, you'll see that 1 selects those two, and if I go to 0, it'll select the opposite. So now what we'll do is we'll take this and create an array between those two. So we'll go here and divide. The count, we'll just say 8. And copy this over to the other line segment. And the reason why they have to be flipped is because otherwise then the first one will go to the last one. So here we'll create a line segment between the start and end. Now with this slider, we're changing the number of subdivisions. I'll disable the preview on everything except for the last line segments. And now what we need to do is take these and move them up and down. There are different ways we can do this, but what I'll show you today is going to be taking these and moving them up. So first, let's set the stage. Move the line segments up in the Z direction. And we'll use a number to change the height. So now let's take this and change the height. And notice that if I just input one number, it's going to change all of them by 1. So to change this, I want to create a range of changes of elevations for this. So we already have the Z vector, we already have the movement. Now we need to see how many line segments we have. So we'll go here to length, list length. When you flatten the input for list length, you'll get how many objects are inside as a number. Now that number can be created, then can be used to create a range of numbers. We'll go to range. Now with this range, we need to set the steps by setting the length. So how many? We need 11 steps because we have 11 line segments. The domain is going to be the repetitions of the pattern. So let me show you what I mean. If I go to construct domain, I can now pick the start and end number that the range starts and ends with. So now let's go here to 4. From 0 to 4, we will bring in a graph mapper. And right click and go to graph types, sign. Now there's different ones that you can play with, but sign is going to be a good example. Kind of show you here. But now we have here we have 12 numbers, but technically we only need 11. So we'll take this and we'll do the length minus 1. Now we can take this and plug it into a multiplication. So we can change the height here by a specific number. So we already have this slider here. We can use that and override. So disable or unplug the one from before, and now plug in the multiplier into the input. Now, when you have the number 4 here, you're going to be creating 1, 2, 3, and 4 different movements. So it's a bit interesting to think about that. Even though you see 2, you're not going to get 2 different mountains or 2 different sine waves. You'll get half of it. So with that being said, we're going to now take those line segments and loft them together. This way you can actually see when we change the height, when we change the number here for the number of divisions. Now this is also going to be dependent on the number of counts. So if you have 10, you won't be able to go more than 10 repetitions. If you decrease that, you would also decrease the domain end. So let's go back to 8, and then here 4, maybe 2. All right, so now let's go to the next part. The next part is going to be, now that we have this taken care of, we're going to be doing it in the opposite direction. So what we'll do is we'll go here to the line segments here. We'll pick the first one. So I'll go to item, list item. Then I'll also take all of those curves and bring in the endpoints. And use an interpolated curve to connect all the start points. Now here, we can take this and array it, relative to this curve. So we'll do curve, or array on curve. using this as the input and this one as the curve. Now the count is going to be in the X direction. So, or in the Y direction this way. So then when we go back here and we look at the Y, see the Y subdivisions. We don't necessarily have those yet. So now with this one, we can change the number of subdivisions. So we'll go here to 10. And we do want to have, well, we're going to be recreating the same thing that we did for those line segments, but for these line segments. Now let's take these, and using the same technique here, where we'll take these line segments, I'll create a relay. So now both of those outputs here are contained within that relay, and I can copy this entire portion of the script to do the same thing that I did to the last part to the new part. And you'll see that this will create like two different axes of change. And I think this is the power of parametric design, right? Is to be able to take a design and be able to change it in more than one way and be able to see the changes right away. So let's copy this over, sliding it over, tapping Alt, plugging this one in. Now notice that it's doing the exact same thing. If we change, so let's see the start and end, list length is going to be how many, and then the height is going to be here. And we know that we can change the number of times that happens. So to see it visually, we'll take this and disable the preview on everything. And we'll bring this over and preview it so we can see it as we change this. Like I said, if we have 10, we can't go past 10 here. Of 10 subdivisions of up and downs. And we can change the height both on this one. So like we can make this one level and just happen on this direction, or we can raise it this way and lower it in the other direction. Now the other thing I haven't talked about is how we can also physically change it here. So if you want to see a visual and change it that way, but in general, if you keep it like this, it's going to be more accurate in the sense that you'll have symmetry within the design, and a lot of the times that's something I kind of aim for. So let's raise this, and so that's going to basically conclude portion of this tutorial. What I'll be sharing with you in a bit is the rest of the work in progress that I've been doing on this. I've turned this into a cluster, and so I wanted to show you the process of how to create this, because when you create a surface like this, you can use it for a reference for various things, and I want to get into that, but for now I wanted to share this with you guys. So thank you very much for being here. Hopefully you found this interesting. If you want to download this, you can go to my website. It'll be there for free for a limited time, so make sure to follow me and subscribe if you want to see when I drop the next script. Thank you for being here, and I hope to see you on the next one.